This problem would have taken us like, I don't know, 30 minutes if we are doing the derivative using the limit definition. But now we have the power rule. We can take care of this in maybe like this little space. Okay, so take a look. We're writing an equation of a line tangent to the curve this at the point 1, -2. So look at what they gave us already. They gave us x equals 1, x value is 1, and they gave us the y value is -2. Y value is -2. Now the only thing that I need to write an equation of a line is the slope m, and you know how to find it. You can find this by plugging in this x value of 1 into the derivative function. So let us go and find the derivative. Y is 3x to the 4th minus 5x squared. So let's use the power rule over here. Bring down this exponent of 4 to the front, and we multiply 3 times 4. You get 12x to the 3rd power minus. Bring down this exponent of 2 to the front and do 5 times 2. That will give you 10x to the 1st power. Okay, so that's the derivative. Now let us find the slope. Slope is going to be the value that we will get when we plug in the x of 1 into the derivative. So let's plug in 1 in here. 12 times 1 cubed minus 10 times 1. That's 12 minus 1, 10, isn't it? Therefore, the slope is 2. So I have my m, x1 and y1. I am going to do the point slope form. Point slope form says I have to do y minus y1 equals m times x minus x1. Let's plug in everything in here. I have to do y minus y1 of -2. So when you subtract the -2, well, that's going to turning into what? +2, right? Slope is 2. That's what we found here. And I do parenthesis x minus x1 value of 1. So you can write this as your final answer. Y plus 2 equals 2 parenthesis x minus 1. Or you can go on and write this in slope-intercept form. If you want to do that, you distribute. You get y plus 2 equals 2x minus 2. Lastly, subtract 2 from both sides to have y by itself. So your final answer in slope-intercept form will be y equals 2x minus 4. Now, both are fine answers, okay? So you can stop on this point slope form on your test, but if your MyLab homework asks you to write it all the way in slope-intercept form, simply distribute and have y by itself, okay? All right, I have another one. I'll do this one too, number 7. This time it says find any points on the graph of f of x equals this function at which a, the tangent line is horizontal. All right, highlight that. This will pop up very often. I love this problem. When they say tangent line is horizontal, guys, what kind of line have, what kind of, I'm having trouble wording this. What kind of slope does a horizontal line have? Think about that. What kind of slope does a horizontal line have? Well, this is telling them that the slope is 0. Okay, slope must be 0. But what is slope in calculus? Well, that's the derivative, isn't it? So what they are saying is, when is the derivative equal to 0? Because that is when the slope is 0, and that is when a line looks at the flat horizontal line. So whenever you see this wording, tangent line is horizontal, set the derivative equal to 0 and solve for x. Okay, so let's find the derivative first. So if that's f, I'll find this using power rule. Okay, bring down this 3 to the front you're going to get negative 3x squared, right? Bring down this 2 to the front, you're going to get plus 12x. Now, what they are telling you to do is set this equal to 0. Don't plug in 0. Set this whole derivative equal to 0. Okay? Whenever you see the wording, find a point where the tangent line is horizontal. That's what you do. Let's solve this by factoring. I noticed that the greatest common factor is negative 3x. So I'll pull that out to the front. If I divide negative 3x squared by negative 3x, I will simply have x left. Now, 12x, positive 12x divided by negative 3x will be negative 4, no more x. So now I'm going to set each of these equal to 0 to find my solution. Negative 3x equals 0. Or, what's the other one? X minus 4 equal to 0, right? So the answer from this green one is simply going to be x equals 4. I'll circle that. And the answer from this orange one, if I divide both sides by negative 3, I'll get x equals 0. So there are 2 points where this tangent line is horizontal. When x is equal to 0, when x is equal to 4, the tangent line is horizontal. Okay, so that's how you can do part A. Now part B, they want you to find a tangent line has a slope of 9. All right, let me try to do that over here. They say tangent line has a slope of 9. You know, slope of a tangent line is the derivative, right? And we found that over here. Here is the derivative in red. Let me copy this down here. What they are asking is what x value will make this 9. So look at what I'm doing. I'm going to plug in 9. I'm not plugging in, setting this derivative equal to 9. All right, now we have to solve this. I may add a new page over here so that I can do the work. So let's solve this. 9 equals negative 3x plus 12x. I'll subtract 9 from both sides to move this 9 to the other side, okay? If I do that, I will get 0 equals negative 3x squared plus 12x minus 9. Notice all of these are divisible by 9, right? 3, 12, and 9. So I'm going to take out the greatest common factor of negative 3. Or, you know, we can just divide by negative 3, really. But, you know, I'll keep it in the equivalent form. So I'll say 0 equals. I'll pull out that negative 3 to the front. But let's divide and write down the leftover inside. So first, the negative 3's will cancel out. I'll just have what? X squared. Next, 12 divided by negative 3 is negative 4. And look at the last term. Negative 9 divided by negative 3 is positive 3. All right, we're getting closer to our answer. So now I'm going to factor that pink trinomial into 2 pieces, okay? So what times what gives you 3? There's only one pair, right? The only way to multiply 2 numbers and get 3 is 1 times 3. But if I make them both negative, I'll be able to add them and get a negative 4 in the middle. So this was factoring a trinomial with coefficient 1. Now, let's solve for our answer. When will x minus 1 be equal to 0? And when will x minus 3 be equal to 0? Well, one of the answer is when x is equal to 3. The other answer over here is when x is equal to positive 1, right? So at x equals 1 and x equals 3, the slope of this tangent line to this curve will have a slope of 9, will be 9, okay? So there are 2 different problems. The first one, when they said tangent line is horizontal, set the derivative equal to 0. when give you a slope of a number, you set the derivative equal to that number and solve for the x value, okay?